Okay, hello everyone, and today I'm going to be talking about using RavenDB in a distributed cloud environment. One of the major strengths of RavenDB is the ability to use it in a distributed environment in many different ways. This is exactly what we're going to do today. So let me give you some context into what we're going to do. We're going to be playing around with the following. We have one application. And this application is actually deployed to Asia, the European Union, and the US all at the same time. For fun, we can mix and match cloud providers and all sorts of other stuff, cloud provider regions, multi-regions, whatever we want. But before that, let's talk about what we actually have. 1 second, there is some cleanup to do for my demos. So here we have a database. This database is actually composed on 3 nodes. This is running in the ASIA cluster. We currently have one database with one document in the system. So this is the setup. Let's talk about theory first before we start playing around with that. So the first thing that we want to do is to understand the distributed nature of RavenDB. RavenDB has 2 parallel modes in which it operates in a distributed environment. The first mode that we have is the notion that at the same at the cluster level, and at the cluster level we have this. You can see it very easily here. We have a leader. This leader is responsible for managing the cluster as a whole. Let's go and look at the same thing from another point of view. Now we are going to look at node B. And what I'm going to want to do, I'm going to introduce a failure into the system. So I can ask RavenDB to restart node A. This is the RavenDB cloud. In a few seconds, this node is going to go down. Here we go. Let's see what happens here. So what happened is that node A was the leader. We switch and it fell down. At that point, node A is down. Node B and C need a leader. And they selected together node B to be the new leader of the cluster. This is done using a quorum, which is another fancy way of saying majority. So we have the majority of the node in the cluster being voting on the same leader. This is done through an algorithm called draft, which is supremely interesting and nice to see. And I would highly recommend that you go and learn more about that. I think we actually have a couple of webinars episodes dedicated to explaining that in depth. And now we can see here node A is back up, but it has been demoted as the leader. And now it's just a normal member of the cluster, which leads to an interesting observation. A RavenDB cluster is composed of 2 types of nodes. You can have a member or a watcher. And what does it mean to be a watcher and a leader? I actually don't have the right permissions because I'm running this on a cloud instance, and I have only the operator permissions that to this, so I can't demo that. I forgot to make sure that I have this capability. But a member is a full-blown member in the cluster. It can become the leader, it can vote, etc. As a RavenDB cluster grows beyond a certain size, typically beyond 7 members, we would stop adding members to that. Why is that? Because a cluster requires a majority quorum for all operations. If I have 7 members, then the majority quorum is 4. If I have 9 members in the cluster, then I need 5, and etc., etc. So the more members we have, the quorum grows linearly, and that's a problem. So for that reason, we have the notion of a watcher. A watcher is also a node that is being managed by the cluster, but it is not eligible for voting or elections, which leads to an interesting issue. So what is it about? And we have to understand that the cluster portions of RavenDB is actually the smallest part, because the cluster only handles managing the cluster nodes. It is responsible for monitoring the health, for checking up, reassigning tasks, all sort of things. And it manages the databases. Let's see how it manages the database. Here's a database. It lives on node C, A, and B. Let's look at that in more details. So this is interesting. Why do we have this order? Well, in the case of databases, RavenDB has the following idea. Each one of these nodes is completely independently and will act in cooperation with the other nodes in the database group. I can make a write to any one of these nodes, and that write would be accepted and operated properly. So far, so good. However, as a client, let's go and look at the client. Here is a client, and you can see that here is the URLs that I have for this cluster on the demo database, which is what we have here. And I initialize and I start making requests. So I'm going to run this code. In a few seconds, you're going to see that we're making requests. Where are those requests? Where do they go? I mean, we have 3 nodes, and we have a database who is replicated on 3 nodes. Let's see. If I'm going to Traffic Watch, I would see that on node A, I don't have any operations. Let's look at what happened if I'm looking at node B, sorry. Again, no traffic. It certainly looks like I'm doing something interesting. Let's try to see what's going on with node C. And hopefully at this point, we might also see a lot of traffic from the, oh, I thought we would see a lot of traffic from loading of the studio. But you can see here are all of the queries that we make. Why are they going to node C? And the answer is quite simple. C, A, B. Let's change things. I want B to be the first one. So I can see that this stopped, and now it moved. So what does it tell us about the distributed behavior of RavenDB? Well, it tells us something really interesting. There is a primary node as far as the client is concerned, and we will always try to talk to the primary node. And you can see that we are able to shift things live. So I switch it, and almost immediately it started watching the other nodes. What's the point of doing that? Remember that RavenDB is a multi-master database. So I can write to any node. But for simplicity and operations, by default, the client is going to select one of these nodes as the first node that it uses. And this is the first node based on the order that it gets. And then it's just going to use that. And it is not going to do anything else until this node is down. So now we can see that we have a lot of reads to node B. Let's introduce a failure. As a reminder, this is the entire code that we have for this demo. There is no error handling. There is nothing that you write. So what I'm going to do, I'm going to force a restart of node B. A few seconds, this one should go away. Previously, we looked at the behavior of the cluster from the perspective of node of the cluster. Now we're looking at from the perspective of the database. What actually happened here, and we can see that this one did not change, and we switched. Why did we switch? And node B went down. Went down in the list, I mean. So the following things happened. We can see it clearly. Node B is down. We have a new leader in town. And we can look at the cluster observer. So part of the behavior of the cluster leader is to monitor the health of all of the databases. And it noticed that node B isn't up. So it moved it to the end of the list. Where is it? Here we go. And it moved to the end of the list. The client responded to that by starting to work here. So it is still running, still operational, everyone is happy about that. So far, so good. Now, I can actually do something more interesting. I can go to the database and ask it, hey, you know what? Let's do round robin. At which point, we should soon see that in all databases, in all nodes on the system, we should start see request. Because now what happens, and we can see it here, add, etc. So what happens is that I'm updating the system configuration, the client configuration, and almost immediately this impacts the behavior of the client. And this is a really important aspect for the design of RavenDB, because it means that as an administrator, you get to do those sort of things and you don't need to deploy or update or something like that. It just works. Now, we can make a write to any node in the system, including different nodes at the same time. And we can see it here. And a write to node C would be replicate to node B and A using asynchronous replication. We can actually see it here in the ongoing task stats. And you can see here the outgoing replication from node A to node C and B, and the incoming replication from node A and node B. Now, I can make a write here, user/2. Let's make another write here, and that would be okay. What I'm going to try to do now, I'm going to try to create a bunch of documents as soon as possible and hopefully create a race condition. Okay, so now I created on all of them. Let's see if I have something interesting. So it looked like it worked. You can see from the change vectors that this isn't globally serial. So here we have user2, and then we have this, which are not quite, so this was created later than this, but A3 and where is that? You can see here A3 and A4. So the node A observed them in a different sequence than what I actually created them, which is exactly what I wanted to show. And the important thing about that is that I can now go and look into all of them and see that we have the proper state across all 3 nodes in the system. So far, so good. But how does it help us? Well, it means that RavenDB's replication doesn't require a cluster, which means in turn that I'm able to do that across different clusters. Let's talk about how we do that. So here we have 2 additional clusters. I intentionally done nothing with them. I created them and let them sit here. So let's go and set up the new cluster. So I'm registering the new certificate. And I'm able to go into the EU. This is the EU node. For ease of use, I'm going to use blue. So remember that the black one is Asia, the European one is the blue. And now I want to create a demo database. And now I have 3 demo databases here, which is fine, which is great, except that now I need to connect the here and here. So now let's think what I need to do. Let's start from this. This is the URL that I want. What I'm going to do, I'm going to go ahead and create an external replication. And let's see. Demo. Now, if I would try this, I would get an annoying error. What's the problem? Forbidden access. You do not have access. Why is that? RavenDB always operates in a secure mode. You can see here, this is secure. So the problem here, the problem that we have here is that when the ASE cluster is trying to connect to the EU cluster, it is not trusted. So we have to teach RavenDB that it is trusted. In order to do that, I'm going to go to the ASE cluster, to the certificates. Then I'm going to ask it to, in the server certificate, export the server certificate. And I'm getting this one. So in here, in the European cluster, I'm going to import a client certificate for this. This is the ASE certificate. I'm going to give it read-write permissions to the demo database. And then I'm going to try to see if this would work. Let's see 1 second. So here is the ASE cluster. It was given read-write permission here. Let's try from another database just to make sure. Okay, this is okay. And this might be, so this is probably a cached error. It would go away in a bit. I'm going to ignore that for now. RavenDB would manage that. So let me add this. So what just happened? What just happened is that they defined a external replication from the ASEAN cluster to the European cluster. And here are the results. And now I'm able to see here user number 4. Let's look to user number 4. And now let's see what happens. If I'm looking at those documents, so we have replication from the ASEAN node C to the ASEAN node B, as expected, and we also have this on node A as well. But this is where it's getting interesting, because we have it also on the European cluster. And naturally, this is going to be applicable on other nodes in the European cluster as well. Here is node B in the European cluster. Now, what happens if I do this? Something really interesting is going to happen. Let's see. In here, well, this is changed. This is great. Here it has not changed. Why is that? This is strange. Well, I defined external replication. External replication is a unidirectional process. So I have to do it on the other way as well. So again, I'm going to here exporting the server certificate of the EU. And then I'm going to go here to the certificates and import that as this. So EU cluster, I'm going to give it read-write permissions on the demo database. And with this, I can now set up the other side. And this is working. Okay. So now this is really interesting because I would expect that. So now think about what's happening here. I've been talking for about 20 minutes. In that time frame, I set up a replication from the EU to Asia, bidirectional geo-distributed replication. Let's do the same on the US cluster. Right now, this is the exact same process. So what I'm actually going to do, I'm going to rush through everything so you're able to see how it works when it is in the flow. And the US cluster, I'm going to use white. And I'm going to be doing this. Let's import the Asia demo. By the way, I haven't yet even created the what's his name? The demo database. It doesn't matter, I can define it up front. Okay, and now I'm going to export the server certificate from the US. Now let's go and create a demo database. And now what I've basically done, I've registered the ASE cluster and the EU cluster in the US cluster. Now I need to do the same in the EU for the US cluster. Here we go, US cluster, demo, we're good. And in the ASE cluster, the same thing. And now we have US cluster. Okay. And now I'm going to do the following. Let's go ahead and create users number 5. It's sad and lonely here because I did not create anything else for it. I set up the permissions, but haven't yet set up the external replication. So let's do just that. Demo to EU. So now we are replicating from the US to the EU. But notice something really interesting. In a few seconds, we are going to flow from the European Union to the ASEAN cluster. So this is an important consideration. And here we go. It took a while, but it got there. That's really interesting. But I don't want to do indirect replication. I want to do that all the way. So now I want to write it from here. But please remember the impact of this indirect replication. It will be very important in just a bit. Demo to Asia. Okay. Now, user 6. And in a few seconds, it should be here, and it should be here. It withdrew. Let me just make sure that this is running. Well, you can see something really interesting. The cluster distributed the traffic, the work. So node A in the US is responsible for replicating to Asia. Node C in the US is responsible for replicating to the EU. That's an interesting observation. So now, what do we have? We have replication from the US to the EU and to Asia. But we also now need to, and here is node 6. Now we also need to set up the other way around. So you can see that we have demo, and this goes to the EU. Let's add it so it would go to the US as well. And somewhere it's here. And here is B. And by the way, notice that most of what I'm doing is relatively boring stuff. I mean, effectively, I'm doing data entry. And this is a wonderful scenario to be in, because it means that I don't have to complicate my life or start editing all sorts of crazy files or something like that. I could just tell us what we want. And now I have set up across 3 different environments: bidirectional, multi-region replication. Here's everything. By the way, it's really interesting to see that you can see the different timing. So on here, 5 and 6 was created before 1 to 4. Now, where does this leave me? What does it give me, all of this? Well, let's talk about the impact that we have. You can see this sucks. You can literally see that this is slow. Let's see how slow. So what I'm going to do now is this. So let's see what's going on. What I'm trying to do now, force request took forever. After a short duration, you can see that the time that it takes me to go all the way to Asia for my location, which is in the Middle East, is non-trivial. On the other hand, let's go and update this here. And this is really interesting. Why is this? Why do we have this? I didn't actually plan to demonstrate that, but this is just amazing. So let's go back and see the behavior that we got. See here. What we have here is read balance behavior, which means that we're reading from different nodes each time. What happened here? I modified the document in the US cluster. It was then replicated by the US cluster to the EU and the ASEAN cluster. So it basically went here. Let's turn this page, save. Okay. So it basically went into one of these nodes. Now, we have to understand something really important about the behavior of replication inside of RavenDB. The common replication mechanism inside of RavenDB is that node A is replicated to C and B, node B replicated to A and C, so we have a full mesh between them. When we have replication between clusters, it doesn't work like that. Because, and you can see it very nicely here, node B is the instance responsible for sending the data to the US. And it is not sending that to, it's not replicating to all of the nodes in the US. It is going to select one of those nodes. Looking into the database scopes, it's going to be, in this case, node B, but let's make it node C just because we feel like it. And now what happens? Node B in Asia would replicate to node C in the US. And then nothing happens. It is not going to replicate to node B and A. The responsibility for doing that is on node C. But node C is going to let some additional time to go by default about 15 seconds, before it is sending those details back to the rest of the nodes in the cluster. And the reason I observe this is that I specified that I have client configuration read balance. Otherwise, I would always see the same thing. So let's look at this now. And again, now the only difference that I have is that I'm running in this, and the state that I have is that I'm running this in without read balance. So without read balance, I'm always going to be reading from node C. So now let's go here and change this back to Oren. And now this operates properly. Even if it takes a while from the write from node C here to propagate here, I'm always writing to and reading from this. This is why RavenDB has this behavior of default primary, because in the more advanced, complicated scenarios, you can actually observe this sort of behavior. And now, let's see what happens if I'm doing the same thing from here. Now I'm updating that in the European cluster. And again, it takes a while, and we should be able to see that shortly. Here we go. Now, just to make sure that I remember, yes, everything is going to both ends. So it took a few seconds, but then it's okay. The reason that it takes a few seconds is because of the topology that we selected. What did we do? Let's see. There we go. So we have a cluster in the EU, a cluster in the US, etc. And modification here flow very quickly. Modification between cluster flow within a few seconds. This is by design because you want to ensure that we don't overload the servers as we do that we don't try to send too much traffic. So we try to minimize that. In most scenarios where you have this sort of behavior, changes are localized. So the New York cluster is mostly working on New York data. The London cluster is working on the London data. And they don't try to read each other data directly. Or at least it's very, very rare. Now, let's assume that I want to go and operate on the EU cluster. So let's just go here and let's add a client certificate. And that would be, second. Let's add, in the European cluster, I have to add my permission to demo. Okay. Now I'm going to say Let's see what happens now. Okay, so he did not like it, which is interesting. I thought I saved that, didn't I? I did not save that apparently. Right, stuff. Okay. There we go. Now let's try doing that. And now you can see that this is the ping time is so much better. And that leads to another really important observation. Why do I want to have a multi-region cluster or multi-cluster setup? Because of latency. If I need to talk to the Asia cluster, which is located here, while I'm somewhere around here, it's going to take longer, in the order of hundreds of milliseconds. But if I'm going to use the European cluster, well, I'm here and they are here. So it's going to be far better. It's probably also going to be better if from here to here, but I don't think that we need to try to test that. I'm sure you will believe me. So now there is another aspect to remember. Let's go and run this. And this is now running. And let's go and make a change in here. Let's change it back to INT. Let's observe what's going on. It's replicating from, here we go. So if you notice, the time frame for that was about 10 seconds or so. And this leads to a really interesting observation about how this works. So I'm always going to be deploying next to the cluster that I want to run on to reduce the latency. The asynchronous application between the clusters is going to handle synchronizing the states in a really nice manner. I don't really have to think about it. I can write in anywhere in the world, and that write is going to end up in all of the other locations, and I still have my fast latency access. Let's talk about failures. RavenDB is a really robust system. We want it to be this way. Let's see what happens if I'm going to take down node C in the US cluster. In a few seconds, node C is going to go down. We should be able to see it very clearly. So a few things happened here. The cluster detected that node C is down. It moved that to a recovery model. And let me go ahead and create another user here. And it moved task away from node C to node A. And when node C would come back up, the cluster will manage its state and will allow it to join the rest of the cluster the rest of the database group as an active member, only once it has completely synchronized everything that's going on. And this is exactly what happened here. You can see that we moved the task over and all sorts of stuff like that, which is pretty amazing if you think about that. Now, what happened if I had a way of killing A, B, and C all at the same time? What happened if we lost an entire data center? Failover is scoped to the level of the cluster. In a multi-cluster setup, I'm not failing over from the New York, from a worker node in New York to London. If you think about it, I don't want to. Let's assume that here I need 2 queries to the database to render a page. That means that these 2 queries are 140 milliseconds. On the other hand, if I'm looking at this in Asia, look at the number. We move from 140 milliseconds to 650 milliseconds. This is utterly insane in terms of additional latency. There is a really famous case study of GitHub where they fell over from the West Coast to the East Coast. And that is an additional, roughly 60 additional seconds in latency for them. And that was enough to effectively take all of GitHub down in a significant manner. So we don't want to do that. So failover is scope to the right location, to the right cluster. The replication and data and your overall system is still fine, but be aware how this works. Now, before we go there, I want to Before we go there, I want to talk about a really annoying factor. I now have another database. And I want that to be replicated across the entire cluster, which means that I have to go and create this database on each one of those other clusters. And I have to go and create the 2 replicas in each location, something like that. This pretty much sucks. You don't have access to that in the cloud admin, but we do have support for server-wide tasks. And if you have need for that, we can set it up for you. So instead of going and manually defining all of these tasks, you will be able to define it once, and that would be applied globally. Just something to remember. Another thing that is important is that so far we only touched on external replication. There is also replication hub and replication sync. This is mostly used when we're talking about edge computation. But you can also use it for this scenario, because then you define, instead of defining one side of this here and the other side, which is in the ongoing task here, you can define just the hub in one location and the sync in the other, etc. It's possible to do so very effectively if it makes sense for your scenario. For our scenario, we don't have a real hub. We have ASIA, EU, and cluster, and the US replicates to the EU cluster, ASIA cluster, the ASIA cluster to EU and the US, and the EU to ASIA and US. So we have a full mesh here. Another alternative is to say, hey, you know what? I'm fine with just routing everything through the EU. So in this case, the hub would be the EU cluster, and I would connect to it from the US and the ASIA cluster. Let's see how that works. We're going to use the flights example. And bird/1. And now we're going to add a hub. We allow replication from the hub to the sync and from the sync to the hub. And we do not want any of the other options. Replicate. And now generate the certificate, generate the certificate. And this will take a second to create that. In the meantime, I still have to go here and create the actual database. Okay. Other, whatever. Here we go. Okay, so save and we're good. Now in here, in flights, I'm able to massively reduce the amount of clicks that I have to go through. And I just set up bidirectional application to here. I hope not here. Here. Too many databases, too many things to look at. And here is birds, and let's do birds 2. And here is birds 2. Oh, we should see birds 2 showing up in a few seconds. While we're doing that, let's do the same thing on here. And I think you will agree that in terms of the amount of clicks and how interesting this is, it is much easier to do it here. Let's do birds 3. Okay, here's birds 1. Birds 2 would soon replicate. There you go. So this time works. And the whole thing would stabilize on pushing everything that is required, all of the other things. And it is much, much nicer to do that through hub replication than the other thing. However, note that as what we have now relies on the EU in the middle. So if we lose the EU, then we lose the connectivity. I'm not sure how big an issue that is. Okay. Another thing that we have to take into account is that if you get to the point where you have multi-clusters or something like that, you probably value your data. So Raven by default is very explicit about, oh, I really, really, really want you to have backups. In fact, in the cloud, you can see that we are backing up regularly. Even this thing was properly backed up. But let's assume that you have a large database. Restoring for backup can take a significant amount of time. So another option that we have is to say, hey, let's use external replication, but let's use it not as a source of a multi-cluster, but just having an offsite backup. Some other instance, something that I can use to ensure that my data is stored in a hot state. So I can immediately change the connection string and switch over to that immediately. And I can do that using external application. I can even do something like this. I always want to be 5-minute delay, just in case something really, really awful happened. But I want to show you something else that is really cool. One of the important properties of wanting an offsite backup is that I want it to cost as little as possible. How does that work? Well, you can see here, this is the power that I assign to the cluster. The nice thing about it is that I can go to a cluster and say, hey, you know what? You're now at 2-core, 8 gigabyte, or probably while you're running in the offsite backup, you're probably this. Now I need you to go to full capacity. And I want this to go to 8 cores and 32 gigabyte. Then I hit save. And let's see what happens here. Oh, this is down. Why is it down? Because I asked it to. So let's see, no day of the US cluster is down. What we're doing now, we are simulating the fact that we have a offsite cluster that we used to have a weak node, and we are upgrading that. So right now you can see that node B is down, node A is down, and node B is up, and C as well, and they are functioning properly. And you can see that this is the amount of power that we have, 2 cores and about 8 gigabytes of RAM that we have available. Now let's go back here and try to understand what's going on. I asked the RavenDB cloud infrastructure to upgrade the capacity of this machine to 8 cores or 32 gigabytes. And the way that it does that is by updating the instances that I have, so they would be able to have additional resources. we are able to take advantage of the fact that RavenDB is a multi-master, highly available system, and just do that while the system is still in the process of being rebooting. And now you can already see that we have the 32 GB applied. There is another process in the background here that would soon update us to the 8 GB, sorry, 8 cores that we want. And node B would soon go down as well to have the same transformation applied to it. So you're able to move to the offsite backup, but if it is too slow, too small for your needs, you can dynamically update that. And you saw that amount of time that it takes. I can actually show it to you live. I have a depth from the last time that we did it. And last time that I spoke about filter application, it was in the context of, again, a hub application, and it didn't work. And the reason that it didn't work was because I messed this up. You can see I had to have a star in the end to allow me to run a prefix. And I forgot that I have to do that, and that was a setting to allow. Okay, now you can see node A is fully completed. Node B is done. The one thing that I want to show you how we are now running. And we start running in a second. Now we're running on the asset cluster. And what I want to do the same upgrade on the asset cluster as well. Let's switch over to 4 GB and 16 cores. And here is the asset cluster. Let's watch what's going on. We keep here is the issue. We have a failure, we recover, we moved on. Slightly higher latency, but unobserved from my perspective. Everything is fine, everything is good, and we can move on with the world. The rest of the nodes in the system, we're good. Everyone is happy about that. And with that, you can take this further and have external application or hub and spoke for local copies if you really want to, but be aware of privacy rules and stuff like that. And this is the time for questions. If you have any questions, I would be very happy to take them. I'm just going to be watching the scene of seeing cluster nodes going down and the client not even being aware of that. This has been a huge amount of work on our part. I'm really, really proud that everything in this demo so far has been seamless, and I've been doing extremely non-trivial distributed system stuff, and everything works. And if I may say so myself, everything looks just really easy. And I have to tell you, it is not easy to make it work like that. So with that, any questions that you have, and we just got that one. Here's a reminder, you can use RavenDB yourself, including using RavenDB for free if you want to try it, both on the cloud and your instances. And we have a few questions. Okay, one second. But we notice that node A is back up. The cluster, the client still operates. You can see that. Let's see one thing here. This is node A on the ASEAN system. It is still updating, but you can already see that it is somewhat up. What is this warning that you have here? Yes, this is interesting. This is probably a bug in the warning because we just started. Oh, we haven't finished updating this thing. That's fine. Okay, we have some questions. So Darjan Bogdan is asking, I saw there is a Terraform RavenDB provider. Is this multi-cluster configuration possible to do with Terraform only? Are there any plan on support that if that's not the case? The question is, you can deploy multiple clusters at the same time, yes, but I noticed that it is now completing the updating process across the board. And now we have recognized that we have 4 cores in the new ASEAN cluster and 16 gigabyte of RAM, and it would move this in a few seconds as well. Going back to Darjan questions. You can deploy multiple clusters using the Terraform provider, yes. I don't think that we allow you to generate replication setups for multi-region clusters. You can use a server-wide task to do that as a default instead, which would probably do what you want. The one thing that you have to remember in general about databases is that they tend to be stateful, which means that just deploying and remove them willy-nilly is not generally something that you do. So the question is that, the answer to the question is that yes, you can do that. It might require some jumping over hoops because this is a really, really advanced scenario. And but yes, you should be able to do that. Okay, we have another question from Claudio Coca. Is this available when using self-hosted RavenDB? And I have a very simple answer to that. The answer is yes. Literally everything that I've shown so far is meant to be used both on the cloud and on RavenDB and on your own systems. You can see us that we are able to do really crazy stuff, multi-region. I could have gone with multi-cloud as well, just as easily. You can do the same as well. You would have to replicate this awesome management studio for the cloud, but I assume that you already have the facilities to do that. Even if I'm really, really proud of this, other people can do a great job too in making the experience of something this complex and non-trivial as easy as this. If you haven't noticed, I'm super proud. I was very nervous about this demo because the number of wheels that are going on is enormous. By the way, notice that we are replacing all of the clusters. Node B is probably, now we are Node C, that this is down. So we are now here, and we almost completed the deployment of new changes. The client is just completely unaware of that. And that's, I think, probably the most awesome thing that I could imagine doing. At any rate, I'm going, we have another one. So from Darjan as well, I saw data sharding on the roadmap for the next quarter. What will be the main difference between feature replication and sharding? The lines are clear for me, so I suppose it is. So let's do it this way. With feature replication, what you can do, you can define a specific paths that would not flow over replication. For example, you may say something like, I want to move all of the users to the hub, but I don't want you to move the invoices, or vice versa. With sharding, you take your database and you split it so all of the users whose names start with A are in node A. All of the users whose names start with B are in node B, etc., etc. So the idea here is that instead of a single database that holds all of the data, you have multiple distinct databases that hold some part of the data. The idea here is to allow you to grow to ridiculous sizes. And from your perspective, we are going to obviously do a big announcement and all of the details around sharding and how they're working, etc. But from our perspective, the only thing that it means is that you're running RavenDB and its capacity for larger data sets in the billions of documents and terabytes of data is just going to grow better. That's the idea. We have another question from Claudio Corca. How does cluster application solve problem with conflict when you have two documents with the same ID created in two regions before application became effective? So that is an awesome question. I kept telling myself that I need to talk about that, and I didn't. So let's go to the demo and understand this. I'm going to create this, and this is going to be user 14b. Now I'm going to go here and create a new document. User 12b. 13b. Here's 14b. This is a conflict. I have 14b here, and I have 14b here. 1 second. And that actually flew from the US to the European Union, the European Union cluster, and overwrote the data. Why did he do that? Because in here, where is it? In here, select the latest version. So, Claudio, the answer to your question is that if you're using multi-cluster setup, one of the things that you have to concern yourself with is managing this scenario. And the appropriate way, so RavenDB is not able to do that, to help you here, because it is unable to coordinate between clusters, because coordination is also only within a single cluster. The typical way you do that is that you say, oh, I'm going to use something like, okay, I'm going to use something like this. Oh, and this gives you the unification of the key to the right location. Another thing that is super important to understand, we are talking about here 3 different clusters. Cluster-wide transactions are cluster-wide transactions. In this case, we have multiple clusters. We have a link to the documentation that explains this in details, and we put it in the chat very shortly. But the basic idea is that a cluster-wide transaction, compare exchange, all of those sorts of things are scoped to a single cluster. If I need to do cluster-wide transactions in a multi-region, multi-cluster setup, I'm going to select one of those clusters as the owner of the data and say, hey, this is where I'm running all of the cluster-wide transactions. The data about those cluster-wide transactions would flow to the other clusters, but this would not. The cluster itself, the transaction themselves would not, just the data they were saved as. So this is a really important, and thank you for reminding me, I forgot to talk about that. Alexandro Poyo, I think it's pronounced. Hopefully I'm saying that nearly right. Are revisions replicated with external replication? I actually have no idea. Actually, I do have an idea. At least I hope so, but let's see. Let's go here and create a revision. And etc. So now I created this on the demo database on the AU. And let's go to the demo database in here. And the answer is that yes, they are. They are being properly replicated across the cluster. So this is what I have. I think that the demo worked. I'm very happy about them. And this is a really interesting topic that can consume a lot of complexity. That can subsume a lot of the complexity that you have to deal with. Sorry, not consume. So in this case, RavenDB is going to be managing the data distribution in a geo-distributed environment, making sure that failover within a cluster works, that the data is shared between everything, and everyone is happy. I think this is it, except that I have one last thing to talk about with regards to all of the tasks that you have. Notice that in this case, I have a backup. In this scenario, in the environment that we have, I'm going to have a backup process running per cluster. If I have an ETL process, if I'm going to throw that to Kafka, I have to decide where is it going to go, assuming that I have a single global Kafka. Probably I don't. It makes much more sense to say I want it on the local environment. But because data flows across all clusters, I have to ensure that I don't have a Kafka operation here and a Kafka operation here, and both of them act on the data that is being written to the database. So in short, RavenDB gives you a lot of really interesting features and capabilities, but you have to be aware of when you actually go to this model of deployment, exactly what you do. So with that, thank you very much and have a great evening. Thanks.